Here's a quick test of the split band compressor. The split band compressors has 4 filters in it. They're at 431 Hz, 736 Hz, 1256 Hz and 2143. They're the mid frequencies of the 4 bands. The Q's around about 1.5 or thereof, so they're fairly broad as well. So this is if you watch the spectrum analyzer, you'll see me talking up there. 1, 2, 3, 4, 5. Now if I turn on the compressor, it's with a compression of about 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Compression about 10. Turn the compressor off. 1, 2, 3, 4, 5. And I can adjust the compression amount from a few dB right up to about 16 dB. Not get too much feedback. 1, 2, 3, 4, 5. Turn it on. That's a compressor on. You can look at the baseline shooting up. That's about 10 dB compression. And that's the compressor off. Compressor on. 1, 2, 3, 4, 5. Compressor off. 1, 2, 3, 4, 5. Compressor on. So that's a quick demo of the compressor. This is the circuit of the split band compressor. You'll notice there are 4 modules. Each one of the modules is a bandpass circuit. The bandpass circuits are centered on 431 Hz, 736 Hz, 1256 Hz and 2143. Speech entering that unit will be split into 4 bands. Each of the 4 filters feeds a diode clipper. I'll just zoom in on that. And the diode clipper will reduce the difference between the high amplitude speech and the low amplitude speech. In other words, compressing. The output of the filter, of the diode clipper, will then pass through another bandpass filter centered on the same frequency as the input pass filter. If you were to pass speech through these diode clippers without any bandpass filtering, you would be generating harmonics. Every time you distort the sine wave, speech sine waves, harmonics will be generated. Level, of course, depending on the amount of distortion. The harmonics, for example, from a 1 kHz sine wave will be at 2 kHz, 3, 4 and so on. However, if you pass that 1 kHz sine wave through a filter centered on 1 kHz, but not wide enough to go to 2 kHz, you will have filtered out the second, third and fourth harmonics. So the output of the second filter will be back to basically a sine wave. However, compression will have occurred if you've gone through a clipper circuit. So the low frequency, the low amplitude 1 kC components will have been brought up and the high amplitude 1 kC components will have been brought down. The ratio between what's been changed and what hasn't been changed, of course, is the compression ratio. It can be 2 to 1, 3 to 1, 4 to 1, etc. The advantage of the split band compressor is that because you're filtering out harmonics that are generated inside the clipper circuits, when you recombine all of the speech waveforms, you pretty well have removed most of the harmonics, and therefore the sound should sound pretty good, as if it hasn't been compressed or hasn't been distorted. It's compressed but not distorted. It's used in some of the commercial broadcast type compressors, and it's fairly effective. Works quite well, up to about 15 decibels of compression. You get a much louder sounding signal, but you don't have a lot of the distortion that would have happened had you not filtered out the harmonics. In this particular design, the first filter is centered on 431 Hz, and the frequency response of the complete unit does show quite a bit of a dip below 500 cycles. The Q of the circuit is quite low, so once I switch the split band compressor on, I do tend to lose some of the lows, but nonetheless the resultant compressed signal does sound quite intelligible, and it's more communication style rather than high fidelity. So I'm just going to play back the audio through the speaker. I can do it through the transceiver, but then you get other complications, including the response of the transceiver system. So you might hear that effect. I've got the microphone on and I'm listening to the monitor speaker. I could go through the transceiver. The effect is a little bit different because of the bandpass filtering in the transceivers, but This will give you a better idea. At the moment I'm just talking into the microphone without any compression at all. Now I'll switch the compressor on and you'll see it's become somewhat more high frequency components and less low frequency components. It is more compressed. I'm using about 10 dB of compression. Might be a bit hard to hear through that speaker, but that's what's happening there. And I'll turn the compressor off while I'm speaking, and now the compressor's off. I haven't changed the amplitude of my voice. Compressor back on, compressor back on, compressor off. So that's a quick demonstration. So here's a demo of the RF tuner on this little monitor. I've got the MP3 player playing into the transmitter, and it's being into the Mark V transmitter, and I'm listening on the Mark IV. And there's the RF coming out. It's actually going to a dummy load, and I've got the probe on this unit across the dummy load through a tap. So as I wind the power up, you can see it go up. It's about 5 watts at the moment. Now if I tune this knob, you'll see that disappears, it drops away, and as I come closer to the frequency, too far, and then about there, I can change the capacitor value, so I have more capacitance or less capacitance, and of course that takes it to another tuning. I can drop the level down a bit, so you get a bit of an idea of what your transmission is doing. If you go to DC on the Crow, you'll get a DC component as well. So if I turn the speech off, then as I wind the power up on say a tone, then I'll get a DC shift. So here I've got tone going in, and you'll watch the Crow, you'll see a DC shift as I up and down the amount of power. You can see the power up on my power meter up there on the tuner. That's 100 watts, that's 10 watts. So I'm transmitting into the transmitter. You'll see it hovering just up to 10 watts. I've got the compressor off. I'll just turn the compressor so I'm talking. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Turn the compressor off. 1, 2, 3, 4, 5. Compressor on. Compressor on. I can wind the compression right down. I'm winding it down. I wind the compression up, higher, higher. And what you're hearing is the sound coming out of the receiver, the Mark V receiver. 1, 2, 3, 4, 5, and there's not a lot of distortion there. I'll wind it back down again. I'll go to about 10 dB compression and turn the compressor off. Compressor's now off. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the press to talk function. You see the light come up on the unit down there. So I'm now transmitting. Turn it off, and I'm now just talking into the room. Microphone back on. That's the compressor switch there. 1, 2, 3, 4, 5. You see the light come on. Turn it off. So both microphones operate the PTT, and the PTT can be switched to either rig 1 or rig 2. This is the stair step into the linear, being driven by the Mark V. You can see I can tune the linear without stressing it too much. Don't want to do it for too long, but that's 100 watts. I can wind it up higher, of course, but just makes it a bit easier to tune. Doesn't have as much stress on the linear. It's a bit like saying Harlow, 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 but using the stair step instead. There's the stair step waveform coming out of the RF detector, going through the linear. You can see it's pretty good. A little bit of an overshoot, but that'll be somewhere in this circuit somewhere. Drop the gain, drop the signal down now. So this is what it sounds like when you tune it, cross it. Here I'll just show you, I've been using the Mark 5 rig, and you'll see the temperature on the heatsink at the back. It's gone to 41 degrees C. Got a real-time clock with a temperature sensor sitting on the heatsink at the back of the transmitter. So as I've been transmitting, it's been getting hotter and hotter. It's quite a hot day here today. There's the power meter going up and the current. It's quite hot and humid here in the room. So let's just give you a bit of a look at the my little monitoring on the Mark 5 rig. There it is there. There's the cable, the red cable that goes into my my little test setup for this demonstration, which is just sitting over there. There's the linear there, and there's the Mark 4, which is picking up the sounds as well. So turn that on. It's not easy to do tests in the shack, because if you get RF into things, you get all sorts of squeals and things. But putting attenuators in and switching attenuators in and out and going to dummy loads, you generally get some idea of what's going on.